Hello, this is Lakshmikant Tiwari. Today I am going to show you how to interface. Hello, this is Lakshmikant Tiwari. Today I am going to show you how to interface a Nucleo-IKS01A1 motion MEMS and environmental sensor evaluation board with the STM Nucleo board. And here I am having a STM Nucleo F. Here I am having STM Nucleo F411 board. So see here, you don't need to do anything. You just plug your expansion board with your Nucleo board. The recommended Nucleo board is 401RE, but I don't have that board, so I am just using a 411RE Nucleo board. But no problem, you can use both boards. Okay. So this expansion board have a few sensors, and those sensors are LSM6DS0. LSM6DS0 is accelerometer and the gyroscope sensor. LIS3MDL is magnetometer, and LPS25HB is MEMS pressure sensor, and HTS221 is a capacitive relative humidity and a temperature sensor. So this board is compatible with the Arduino Uno R3 connectors. So it means you can connect this board with your Arduino as well as with any Nucleo boards. Either the Nucleo board is using L4 or L series of microcontroller or F series of microcontroller. It doesn't matter. It could be the F microcontrollers such that the Cortex M4 or Cortex M7 or Cortex M3 microcontrollers. Fine. So here this one is the HTS221, and the next one is the LPS25HB, and the third one is the LSM6DS0, and the last one is the LIS3MDL. Okay, and this one is the Arduino Uno R3 connectors, and these are the STM32 connectors, and here is the DIL24 pin available for additional MEMS adapters. Let's go to for the next slide. Into the next slides you will find that the connection of these sensors with the boards. Okay, so the LSM6DS0 have only one interrupt pin, and the LIS3MDL have two interrupt pins, and the LPS25H have one interrupt, and the HTS221 have one interrupt, and the DIL have a two interrupt. See, so these interrupts pin actually tells this microcontroller, okay, this Arduino Uno R3 Marfo is connected with your Nucleo board. So this interrupt pin tells the Nucleo board, okay, I have computed a new value, please take it. Okay, so after the interrupt generation, then the Nucleo board reads these data value through I2C address selection and the I2C bus. Okay, so all sensors have I2C address, so you need to first select the address, okay, of a particular sensor, and then read the value through the I2C bus. So here are overall software architecture of the programming. So see here into the overall architectures. Let me describe you how it works actually. Okay. You know, for a programming you need a set of hardware and a software. See, so software, when you are going to write a code from a scratch, it takes a lots of time. But here ST have made all these things very easy by combining a library into the STM32MX. Okay, so from the top view, if we see, so the first layer will be the application layer, where user will write its own code. Okay, so here the some sample application has been already provided. Okay, by using these sample application or sample projects, example projects, user can create its own project. Okay, the user can make some changes into the sample projects to make their own project to be running. And then there is serial communication and middleware protocols. Into the middleware, a serial virtual COM port is given onto the STM32 CubeMX so that user can see the sensor data into the PC. Okay, and into the side the utility, some utility is given such that there is Java file or some other files is given to see data onto the COM port. Okay, it is provided by the ST. I'll show you. Okay, I'll show you. And the CMSIS is a Cortex microcontroller software interface standard. The CMSIS is used for a DSP computation, okay, digital signal processing computation, where you need to do some FFT or matrix manipulation, regression, autocorrelations, digital filtering. Okay, so all these things have been made easy by using CMSIS. And after these two layers, application middle layers, a driver layers comes. Okay, into the driver layer you will find a hardware abstraction layer API. So it is known as HAL layer. Okay, HAL API, hardware abstraction layer. And parallelly there is another support package that is known as a board support package, that is the BSP. A hardware abstraction layer is very closely connected with the hardware register level, and the board support package provide supports at the board level. It means there is a difference between these two packages. The hardware abstraction layer actually provide means hardware layer programming, means suppose that let me make it clear. HAL give you on a register level programming, but here board support BSP give you a function, okay, which utilize HAL function. So BSP utilizes HAL function, but HAL is written at the register level. And after this driver layer, hardware components come. Okay, the STM32 microcontroller, HTS sensor, LPS sensor, LSM sensor, and LIS sensor. Okay, so how it works? The application layer is connected with the driver through the middleware. Okay, and the middleware is a serial communication protocols, and the drivers will run on hardware components such as STM32 microcontrollers, RHTS, LPS, LSM, and the LIS sensor. And the hardware components, okay, and all those things will be running on a board. Those boards are STM32 Nucleo board and the X-NUCLEO-IKS01A1 expansion board. Okay, fine. Now let me show you whatever I have told you here. So these are some software which you will be needing to program your STM32 F401RE or F411RE Nucleo board with the expansion board. But before this software, you will be needing Gale Microvision. Okay, so here is Gale Microvision. You need to first download it. First fill your contact information here. Okay, then you select the for which purpose, for which device you are using and for which purpose, and submit it. Then a new link will come there, and from there you can download the Gale Microvision. So after downloading this Gale Microvision, you need to download this software. Okay, I'll be giving link into the video description so that you can directly download this software. And see the license wizard. This license you need this license to run the OSX Motion AR, that is the activity recognition softwares, and other sensor fusion softwares. for running this motion activity recognitions and other motion sensors softwares or sensor fusion softwares, you will be needing some license. Okay, but there are so many other examples has been already given into the STM Cube expansion MEMS1 version 2.1 folder. You just go inside this folder. Now let me show you. I have already described there the utility folder. Into the utility folder you will find a PC software for a sensor data log. Okay, if you open it, it will show you sensor data log, and it will show you the COM devices which will be connected with your computers and the speed, that is the baud rate, and it will be showing you pressure, temperature, humidity, accelerometer, gyroscope and the magnetometer data into this data logger. Okay, I am using a Windows 10, that's why it is not running on my computer, but if you are using Windows 7, of course it will run on your computer. And into the driver, see here there is 3 folder. The first one is the HAL, hardware abstraction layer. Fine. So you will need this software package as well as this BSP, board support package. Here is board support package for a Nucleo code. Okay, and here is the CMSIS. Into the CMSIS you can find the Cortex microcontroller software interface standard library files, and after the driver here is the projects and the documentation. Fine. Into the documentation you can find the documentation about the Cube expansion MEMS version 2.1 software package. But here is a project. Into the multi, there are lots of examples are already given here. Let me open a data logger example. Okay, so then to the data logger examples, either you can use if you have IAR or MDK, Gale MDK. Okay, so just open Gale MDK 401RE and open it. Fine. And if you open it, you can find there is so many program is already written here. Okay, I mean the code example code is already given here. Okay, so you don't need to write or change anything here, but of course it is very big program, so it will take time to you to understand these codes. So I want to show you here. First of all, that let me explain you this, what is these folders. Okay, see, the first folder is the source folder. Okay, into the source folder the user written file is only the main file. Okay, the COM file is a self-generated file by using STM32 Okay, you don't need to change anything here. Okay, and the main file is of course this one, and here is the BSP file. You know, into the BSP files, so the HTS sensor driver files, here it is already, all those things is given here already. Okay, the driver version if you want to, the device ID if you want to get the initialization, configuration initialization, deinitialization, and the get measurement. Okay, if you call these functions, it will return you the temperature and humidity. And here is the get the raw data measurements without any conversion. Fine. And here the get humidity raw, and from here you can get humidity, use the conversion, proper conversion, and here you can get a temperature, and here you can get a raw temperature data. Similarly for a magnetometer, okay, and for accelerometer and gyroscope, And for a pressure sensor, if I open it, you can see here into the pressure sensor folder file also there is a power mode selection and get power mode. Fine. Low pass filter cutoffs. Means you can set actually these things just by calling these functions. Now let me show you hardware abstraction layer files, HAL files. HAL files is here. So these files are written on very register level and the microcontroller level files. Here you can find the DMA, the GPIOC files. Okay, these are the very big and the large files. It is already written by the ST microelectronic engineers and it is given with the STM32 such as HAL GPIO initialization and HAL GPIO deinitialization files, GPIO read pins, GPIO write pins. So all these things has been already given. Only you need to understand what files means, what is your purpose, what will be your pseudocode or code flow, so that you can actually use these functions very easily. Fine. And here is the examples, the startup files. So these files have been already given. Only you need to write this main file, and also you need to know, means at least you must have some knowledge how to use these means already given library files. If you want to see the functions which are available to the users, you can just click on a functions, then you can find a list of functions which is available for a user. Let's see into the magnetometer. Okay, here is a magnetometer. So these are the functions which are available to use, such as here see the magnetometer full scale, data XYZ, overrun. Okay, so these are the some functions which are available to the user. So user can directly call these functions. Okay. Now let me explain you this main.c file little bit. Okay, I don't have much time to explain all these functions. Okay, if I get some times, I'll explain it someday. So here are some private variables are declared, such as sensor enabled, data tx period. So at every 1 second you will be getting a new data on your COM port. Okay, and just I remembered by COM ports. Let me show you a COM function. Okay, here is a COM and you need to get here baud rate. Okay, the baud rate is 921600. Please remember it. You will be using this baud rate into the Terra term or putty. So here is accelerometer value and the gyroscope value and the magnetometer, pressure, humidity, temperature. Okay, and here it is current time 1 and current time 2 for a timestamp. Now come to the main. Into main, of course, first of all that you need to initialize the hardware abstraction layer and then the system core clock configuration, board support package, LED initializations. Okay, then it will initialize the buttons in UART configurations and RTC configuration. Then initialize all sensors, then enable all sensors. Then it will you will be transferring here from here the data. Okay, now here you are transferring the data to the computer. Then this is initialize all sensor. You see here, just it is calling a board support package, accelerometer initialization, gyro initialization, magneto initialization, humidity and the temperature and the pressure initializations. You don't need to write anything. You just need to understand how to call these functions from a library. Here enable all sensors, just it is calling a BSP support package files, support package function, and float to int conversion, RTC handler, accelerometer sensor handler. So into the RTC handler it is transmitting the timestamp. Okay, you can add here a new carriage written with the okay. So accelerometer sensor handler, gyro gyroscope sensor handler, it is transmitting the gyroscope data XYZ. Magnetometer sensor handler, it is transmitting the data XYZ. Okay, first of all that it is converting this data into the character. Okay, means a set of characters, then transmitting using a HAL UART transmit package. Okay, and then here is the pressure sensor handler data, and then here is a humidity sensor handler, and then here is a temperature sensor handler. Okay, and then here is a RTC configuration, and then RTC timestamp configuration. Okay, so that's all. Okay, there are some more functions. So it is going to be almost 700 lines of code, but the code size, if we compile it, and find its code size is very large, actually the 51 KB code size. And if we do some tweak in this, so we can minimize actually the code size. How we can do? We need to optimize it to the level 3. Okay, let's see if we optimize it to the level 3 and recompile it, rebuild it. Let's see what will be the code size. Initially it was a 51 KB, and after the compilation, let's find what will be the final code size. See, the code size has been decreased drastically, the 41 kilobyte. And into the map file, actually you can find the compilation code, means the compile code, means what I can say, where your compile code is placed into the memory and how much memory it takes. All these things you can find this to this dot map. Okay, if you take it very clearly, you can find the address and other things. These are some advanced programming techniques. I think you don't will be. I think you don't need these things. You can find out from here which function is taking a more, means which function is actually taking a memory. See, here it is written everything. Fine. So this function is taking 232 bytes of memory. This function is taking only the 2 byte of memory. From here, suppose that if you are running out of memory, you can actually find out which function is taking more memory. Okay, so here the thumb codes and the size and other things has been given, and where this code is placed, the address. And here the image has been given. Okay, so which function is taking more data, more value. Okay, let me show you. One more thing I want to tell you, the code size is large. Because of that, we are also generating a debug function, means a debug information in our code. If we suppress a debug informations, then the code size will be decreased more. Okay, so 11 KB this main is taking. Okay, so something like that. The total object file is almost 1 MB total object file, including the debug and other things, but actually then the other things has been removed into the final binary files. That's why it came to around 39 KB. Okay, fine. So the library total is taking almost the 4 KB, and the total memory is 39.61 KB. Okay, so these are some memory and other things. So for advanced programming techniques, if you are running out of memory, so that you can actually find out which function is taking, means how much memory, so that you can optimize your code actually. Now let's burn this code into the Nucleo board. Okay, so let me show you. First, our board is connected. You can go into the debug and into the setting. You can see here ARM core site SWDP is connected, and the serial number of board is this one. So that means the board is connected already. Fine. And from here you can load the function. You can load the hex file into the board. Now it is programmed and verified. Everything is okay. Now let me open a putty for you. Okay, so open a putty. Here I have a putty or a teratom, you can use anything. So into the serial COM port, have you remembered that baud rate 921600? I have shown that one, and open it. Now see here, here I am getting the data. See, if you can see here, so I can show you the humidity is almost 50-51 and the temperature is around the 27 degrees Celsius. The accelerometer value x minus 32, y is minus 2, and the z is 966 or something. So you can see see here the gravity, the earth gravity, the static earth gravity is 9.6 here. Okay, it is differ from 9.8, the general gravity here. Okay, and here is a gyroscope value and here is a magnetometer value. Fine. And now let me disturb my board. Now I am disturbing my board. You can find here the value is changing. Okay, here see accelerometer and the gyroscope rotation value, everything is changing so drastically, but the temperature and humidity, other things are same, and the pressure value is also same, and the timestamp, see the timestamp is showing you here the running time. Okay, so here it is 15-16 seconds. Okay, since last 18-20 seconds our code is running here. I think it has been more than 1 minute, I think. So we can say 1 minute 26 seconds. I think it has started from 8 hours 10 minutes, I think. Let me see. Let me see. Yes, it started from 8:10. Okay, so 8 hours 10 minutes. Fine. Okay, so similarly you can utilize this code according to your need. Okay, I'm not going to describe all these things into the very detail because of that I don't have much time. Okay, thank you so much for watching this, and I hope it helps you. And if you have any problem, you can mail me regarding your problem, and also I am attaching this program into the video descriptions of the link of this program so that you can download it. Thanks for watching.